Here's Dr. Romano now. I hope he's not mad that I did take cover on your porch, Dr. Romano. Is it okay?
Yes, I believe it's okay.
I saw you were doing some work again. I brought you some coffee.
I really don't want any coffee, but I do want to do some organic chemistry, so let's get right into it. What I want to do here is I want to compare the acidities of three molecules. Here we have ethanol, here we have ethane thiol, and here we have acetic acid. If we wrote in the pKa values of an alcohol are around 16, of a thiol around 10, and the carboxy acid here is 5. The minute you look at this, you see that this is the most acidic compound because it has the smallest pKa value. This has the highest pKa value, so it's the least acidic. The question is, though, why, though? And this is what I want to kind of go over with you as to explain why the pKa's vary so differently. What I tell all my students is 3 words. Examine the anion. So if you look at the anion of this, meaning you take off the H and you put in a minus, we get CH3, CH2O-. That's my starting point. So as you can see, this anion has the negative charge resigning on an oxygen. And we gave that a value of 16. Oxygen's a negative element, so it can handle a negative charge. How about now? Why would the ethane thiol be so much more acidic than the alcohol? If you look at the anion, you have a sulfur atom. Since sulfur is underneath oxygen on the periodic table, it's bigger. Now you might say to yourself, what does that mean, it's bigger? It's bigger, and therefore it will allow this negative charge to be spread out or dispersed to a greater extent. And therefore, if we examine the anion, it's better to have the negative charge dispersed over a large area. If that's being the case, it would cause this to be more stable. If the anion is more stable, that means the compound is going to be more acidic. If we look at this compound here, acetic acid, there's something else at play here. As you can see, the anion has resonance. So resonance is able to disperse the negative charge, and as you can see, resonance is a very powerful factor when it comes to stabilizing a charge. So in this example, the negative charge is going to be spread out to a much greater extent than either one of these could be. So that would mean that that anion is much more stabilized. Having a stabilized anion gives much more acidity to the compound. If I ever ask you how much more acidic is acetic acid and the thiols, you can see from a 10 and a 5, if you subtract a 10 from 5, you get 5. So that means you would put it to the power of 10. That would mean that this compound, acetic acid, is 1 times 10 to the 5th times more acidic than the ethane thiol. So anytime you get an acidity problem, the best way to approach it is to remember 3 words that I bang into my students' heads. Examine the anion. The greater the stabilization of the anion, the lower the pKa of the acid, hence the more acidic the compound will be. All right, I hope that helps and gives you a good understanding of how we do questions on acidity.
You sure you don't want that coffee I brought, Dr.
No
Romano?
coffee. Hopefully, when I leave, I'll come back and I see you gone. Good day to you.
Okay, Dr. Romano. Sheesh. Goodbye.